Hey, what's up? What's up? It is Thursday, May 8th. You know what to do, so pause the screen if you need it. I'm going to keep moving forward. Again, pause the screen, get this in your agenda, and we're going to keep moving forward. Okay, this was from Tuesday. So I know some people did not get to see this, so I just thought I'd put this up there. And that's somewhat what it looked like on Tuesday. And again, I just wanted to reiterate, when you're going out there with your moon observation journal, you do not have to go out at night. This was taken around between like 5 and 6 o'clock. So definitely do that. Some people were going to practice between 4:30 and 6:30, and they were observing the moon. I tried to observe the moon this morning, but because where the moon is and the sun is close in the sky during this time of year, you have to go out really early, because once the sun starts coming up, it is hard to see. So I'm going to see how early. I didn't look early enough, apparently. So we'll keep trying. This is what the moon looked like last night. And I do want to clarify this. Remember, the moon starts rising at about 3 o'clock. And then that is the same moon all night into the morning. So if you go out there early enough to be able to see it in the morning, it's still the same moon, because the moon's like time in the sky is overnight. So just remember that. So go ahead and draw this one in, and that would be for the 7th. So that would be your second observation for Wednesday. This is the moon from May 7th, okay? And again, do not put a time. Put that you got it from Mr. Farr's class, okay? So go ahead and put that, and that you should have at least 2 in there. I think I'm going to update my slide. So cool. So I'll do that for tomorrow. So Earth, Sun, and Moon systems. We're going to talk about astrophysics a little bit, and that's basically how out in the whole galaxy, in the whole space, how does physics work? So we've talked a lot about physics here on Earth, but now we're going to talk about how do those same things apply out on Earth. We'll talk about the difference between astrology and astronomy. We won't talk too much about astrobiology, just a tiny bit. Okay, let's keep it pushing. I did want to just show you guys this real quick. I'm going to turn down the volume on this, but I did just want to show you guys this so that you can kind of see these are the kind of systems and rotations and patterns that we see. And again, I do want to make sure that it is clear that the sun is about 1.3 million times the size of the Earth. So this model is not to scale, but it is not built for scale. It is built for understanding, so that we can kind of get this idea that the sun is rotating, so it's just spinning on its own axis, so it's just rotating, and that the Earth is rotating on its own axis, but it is also going in a revolution around the actual sun. So that would be about 365 days. That's what we call it, 0.25, right? When we talked about what that 0.25 is and how we calculate for that in the leap year. And then you also see that the moon is also revolving as a revolution around the actual Earth at the same time. So the moon and the Earth are going all the way around the sun, right? But then the moon is just revolving also around the Earth at the same time. So I just wanted to get all of those things in there. All right, let's keep it pushing onto this. We talked about this already, so we're not going to go through that. We're going to push through that. I do want to say this. I misspoke the other day when I talked about the tilt of the Earth. So I wanted to just make sure to clarify that the tilt of the Earth is 23.5 degrees. Now, when we talk about, like, you guys know about y-axis goes up and down, right? And if our north and south pole are our y-axis, then the tilt is about 23.5 degrees on that axis. So hold on, let me get, if the north pole and then the south pole, if that is our y-axis, then the Earth is tilted about like this, right? And some planets have like a 90-degree tilt, which would be more like this or like a little bit further down, right? So some planets are tilted way more than that. So I just wanted to make sure to clarify that. Also, let's just look at this for a second. So go ahead and turn to page number 48, or 49. That's where we were at the other day. Now we're at 48. 48 is a blank page. This question down here, why does the shape of the moon appear to change over time? Write that question down, and then I want you to think about it and answer it on your own. We are not going to discuss a lot about that right now, but I want you to think about it and see what you think. How is it possible? See, and you see that this person right here also did something similar to what you guys are doing and taking that journal. Why is the shape of the moon appearing to change? Because we think in reality the moon is not changing its shape, that it's staying this same shape. But then why does it look different in the night sky? So that is something you guys, I want you to answer that question. So again, pause the screen, write this question down at the top of page 48. It is a blank page, and then go ahead and write your answer. Mr. Farr is going to move forward. All right, pause the screen. Cool. So one other thing, as we are taking our journal and we're notating through the phases of the moon, I want you to think about, is the moon, and if you look over here, it's smaller, then there's more appearing, and then we get the full moon, and there's less appearing. Which phase of the moon are we in? Are we in this phase right here where we're going towards a full moon, or are we in this phase over here where we're going away from a full moon? So that's something to think about. We asked this question in class, and we could not get a consensus. Some people are like, it's getting bigger. All right, hold on. And other people put that on everything that it's getting smaller. So we'll just see. So let's go ahead and get down to everyone's favorite time of the year. It is note-taking time. I am not gonna be pausing, so you need to pause as you need to take notes. All you have to take notes on is that definition over there. So moon, a celestial body that revolves around a planet. Okay, so moon revolves around a planet. Now, typically when we say the moon, we mean the moon that Earth has. Now, here's the thing is, there are multiple other planets that have moons. Some have a lot, some have few. And guess what? Some planets don't have any. And we've kind of talked about that a little bit earlier this year. Also, something to think about is all of these crevices here on the moon, all these craters are from collisions and impacts. And is that helpful or good for us? Yes, it is, because it's kind of like a shield that kind of goes around and kind of helps deflect some of the impacts from being on Earth. Now, something I did, because you could fit about 50 moons inside of the Earth, so I thought I would do a little scale. So I got about 50 ping pong balls. And so this is really the scale about from the Earth to the moon. I know this is rudimentary. Oh my gosh, here we go again. This is about the scale right here of about 50 ping pong balls. So this is one. So this would be the moon, and this would be the more accurate scale of the Earth. Now, I'm not going to use that because that thing looks crazy. You know what I'm saying? So I'm going to use this. But again, this is probably more like almost 75 to 100 times more. So it's not the same scale, but again, it is for learning purposes. All right, let's keep moving. Pause the screen if you need it. Okay, so phases of the moon. So phases of the moon is the shape of the illuminated portion of the moon as seen by an observer, usually on Earth. So again, phases of the moon is the shape of the illuminated portion. So the part that's lit up portion of the moon as seen by an observer from Earth. And again, it's our perspective. If we saw the moon from outside of the Earth, right? So if we were like this and we were observing from over here, the moon would totally look different than the way that we observe it here from the Earth. Okay, cool. Now we're going to talk about constellations and the sun. So let's just go here. First things first, a constellation is a group of stars that form a pattern in the night sky when viewed from Earth. And when I say we, I just mean humans, have given it meaning or say, that's what we think that it looks like. So right here, this is a very common one that people see, and we usually call that like the Big Dipper, right? We've got another one up here, and sometimes we might call that the Little Dipper. Some people are like, oh, I remember I saw the Belt of Orion, and he has a bow and arrow. All right, cool. And again, we've given them names. We said it looks like things, and we'll look at some of these constellations and what are their names, and we'll just ask, do you think it looks like what people said it looks like, right? Okay. Now, as we keep pushing, again, pause the screen if you need it. I'm going to keep going. A star is a celestial body consisting of a mass of gas held together by its own gravity, in which energy is generated by what we would say nuclear reactions. So we'll talk about that for just a moment. So I do want to say this. The biggest things is a celestial body consisting of a mass of gas, and it's held together by its own gravity, right? And its energy, the way it gets energy, is from nuclear reactions. Those are the things that I would point out that are important. Remember, a star is gas. It's held together by its own gravity because it's so massive. Remember, you could fit 1.3 million Earths in our star or our sun, right? And the thing about our sun is it's not one of the bigger suns. There's much larger ones out there. So let's go ahead and keep going. I'm going to go ahead and turn this off right now. Boom. And then here's the sun. The sun is the luminous star. And when we say the sun, we mean our sun here on Earth, right? So we're not here on Earth, but it's the sun in our, or the star in our solar system. So our sun is mainly composed of hydrogen and helium. Now, when I say hydrogen and helium, I mean just like we just went over the periodic table. So hydrogen, it is mainly composed of hydrogen, and it's ramming those hydrogen atoms together. If you guys remember, hydrogen has an atomic number of 1, which means it has 1 proton. And when it rams those hydrogens together, then guess what they become? Because it does nuclear fusion, so it fuses together, and it becomes helium. So this is often a question that people ask. They ask, yo, how does the sun burn if there's no oxygen inside of space? That's because the sun does not burn. It is using nuclear fusion to actually create the energy and these explosions and all the energy that's coming and the light that's coming out of that. So just realize that. Okay, and I think we are on to the last note of the day, and it is the solar system. Boom. Or solar systems. And that's a star and the group of planets and other celestial bodies. So that could be like the moons. Sometimes it's like asteroids that are inside of that solar system, right? That are held by the gravitational attraction of that star and revolve around it. Now, if you look at this picture here, this picture is more what we would say to scale than that model we were looking at earlier. Now you can see how big the sun is, and then look at where we are right there on Earth. Look where we're at, really tiny. So that is more to scale of what you actually see out there in the universe. So I just wanted to put that out there. This is a good picture because it's more to scale. It's not 100%, but this is more to the scale of what things really are. And if you notice, these first few planets are really small, and then the larger planets seem to be further away. Now, why is that? Why is that? What do you know about gravity, right? What do you know about gravity and its effects? So again, that is the last note of the day. So hopefully you got all of those things. And then we're just going to take a look at this. So we're going to look at the constellation star map. And then you just see, and I'm going to put myself in the center where the sun and the earth is at. And do you think, that these constellations look like those things? And some people are like, aren't these a set of beliefs? I'm like, no, if you go back to the Latin words, they mean what you see. So like this word Cancer actually means like crab, even though that looks more like a lobster to me. Okay, cool. So like Gemini actually means twins. And I would have to go look up because I don't know all of them. But a lot of them are literally one-for-one like translations of what people thought that they actually look like from our observation point in or on Earth. And remember, that is what the stars look like as we are here on Earth. So we'll do a little bit of a demonstration with that tomorrow in class. That is everything. All right, y'all. Peace.